our topic is continuity at a point. We have discussed the continuity in a global sense. What it means? It means that we discuss the continuity on the whole domain. Now we will discuss the continuity or a continuous function in a local perspective. What it means? It means that now we will discuss the continuity or a continuous function at a point of a domain. Now let us see the definition of continuity at a point. Let we have a function f from a topological space x tau x to y tau y. Now this function f is continuous at a point x of x if and only if for every open set containing f of x, and I denote this open set as u f of x. What is this? This is an open set containing f of x, and of course this open set is an open subset of y. For every open set there exists an open set of x containing x such that Vx is contained in the inverse image of this u f of x. Or one may say that f v x should be the subset of u f of x. So if for some point x I can find a Vx corresponding to every u f of x such that this condition or this condition, one and the same thing, both are the same things, holds, then I say that this function f is continuous at that point x of x. Now if I want to check the continuity of a function at some point, what I have to do? I have to do the following three things. Number one, so basically this is a stepwise working. If I want to check the continuity of a function at some point of the domain, the first thing, you have to find the f of x for a given, of course, for a given x belongs to x, you have to find first thing f of x. Then you have to collect all the open subsets of y containing f of x. That is, you have to write this class. I denote it as u f x, and this class consists of the open subsets of y containing f of x. F of x belongs to each u f of x, and this is a subclass of tau y. Then the last and the most important thing, for each element of this class, say that element is u f of x, you have to see is there exist some Vx such that Vx is a subset of f inverse of u f of x. If the answer of this question is yes, for every element of u f of x, if your answer is yes for all u f of x belongs to the u f of x, then you can say f is continuous at x. But if there exists some u f of x such that there exists no vx, such that vx is the subset of f inverse of u f of x, then you say that f is not continuous at x. सो बेसिकली थर्ड पॉइंट पे जाके हम ये डिसाइड करेंगे कि हमारा फंक्शन x पे कॉन्टिन्यूस है या नहीं है. कॉन्टिन्यूस कब होगा? जब फॉर एवरी एलिमेंट ऑफ यू एफ ऑफ एक्स देयर एग्जिस्ट अ वी एक्स, बट इफ देयर एग्जिस्ट सम यू एफ ऑफ एक्स सच दैट किसी भी केस में आपका आंसर नो होता है, बट इट मीन्स देयर एग्जिस्ट नो वी एक्स सच दैट दिस कंडीशन होल्ड्स, सो यू मे से दैट f is not continuous at x.